Hello, my lovely applied mathematicians, humans or otherwise. Um, so, what we're looking at today is horizontal circle from 2024. Let's write that up before we go. So, 2024 horizontal circular motion. So, in the stunt cage of a circus, a motorcyclist performs acrobatic stunts in a hollow sphere of diameter 20. So, diameter is 20. Okay, cool. Motorcyclist and motorbike labeled M have combined mass of M. M moves with uniform horizontal circular motion. Excellent. So we got some horizontal stuff where that means our up forces have to equal our down forces, which gives us something to work with. The line from M to the center of the sphere makes an angle beta. Beta is tan inverse of 4/3 with the downward vertical. So before you do anything, I see so many students who find out what the angle beta is, and then when they've got to get cos and sine of that, they put that into their calculators and get a close approximation to the answer. But if it's tan beta is 4/3, that means 4 is the opposite to beta, 3 is the adjacent, and it's a 3, 4, 5 triangle. So we know that's that, if it will let me draw it. And we also then know that cos beta is 3/5 and sine beta is 4/5. And we don't need to go near our calculator again. If we write down cos beta, we know it's 3/5, and we've saved ourselves tons of time by just having a nice little bit of trigonometry to get us started. So a student models the motion of M. In the student's first modeling iteration, friction is ignored. First modeling, so there's going to be a friction led or friction heavy second part, I imagine, so eq. So draw a diagram to show the forces acting on M. So we have M, and what's acting on M? Well, presumably we are on Earth, so we have mg down. We haven't said otherwise, so we have mg down. And then what else is happening? Well, the only point of contact is with the surface of the sphere, and there's no ropes or tension and anything else like that. So the only thing we have going on is that. Or those are the only forces acting on the motorbike. The sphere pushing back up perpendicular to the surface. And if you want to, you can put a little line in here just to show that you're on the surface of a sphere. You can do that if it helps you. You don't have to, but it often helps me to be able to visualize what's going on. So that's what's going on, and that has that angle beta as well, because the reaction is always pointing to the center of the sphere. So okay, well, that's part one done. Okay, cool. Sorry, I'm already thinking about how I need to solve this, but that's part one. That's the diagram done. Part two then is calculate the velocity of M. So we want the velocity. So that means we are on our circular motion equation, mv squared over r. So we want to calculate the velocity. So we want to be able to get that. We want the mass and the radius. So what is the radius? And this is the mistake so many students make, and I made when I was prepping this a couple of days ago. The radius of the circle is not 20, because the radius of the sphere is 20, but the circle that the motorbike is doing one not being a pain again. The radius that the motorbike is doing is that little or there. So that is supposed to be an or anyway. So that little green line is the radius of the circle the motorbike is making horizontally. So we can get that out. We can get this though using that angle beta, because we know that that line is 10. It's half the diameter. It's the radius of the sphere. So we can get little or, and this is what we have to do for all of these things where we have a string of length or a circle or something, or a circular motion in a cone or something. We have to make sure we're getting the right or. The or we're getting is not necessarily the or of the object in which the thing is moving, it's the size of the circle that's actually happening. And in that case, it's that or there is the radius of the circle that's happening, and that is sine beta is or over 10. So we have, from that little diagram, I'll just leave it here. From the diagram, we know sine beta equals or over 10. But we know we've worked out what sine beta is 4/5. So 4/5 equals or over 10. I think that means or has to be 8. So the radius of the circle that's happening is 8 meters. So we have mv squared over or. So that is m. I think m is just a mass. Yeah, we're told that the combined mass is m. So it's m v squared over 8. And that's the force that is causing circular motion to happen. But how do we relate that to our force diagram of or and mg? Well, if we go back to our picture here that we've done, our or is a diagonal, our reaction is a diagonal. And when we decompose that into horizontal and vertical parts, we get the horizontal part is or sine beta, and the vertical part is or cos beta. Just let one note catch up if it's going to, or cos beta. But we know the ups equal the downs. So we know that mg has to equal or cos beta, because that vertical force is balanced out because it's moving horizontally. It's or cos beta, and cos beta is 3/5. So this means that mg equals 3 or over 5. Now I don't know if we're going to need to rearrange to get m equals or rearrange to get or equals, but so I'll leave it there for now. The other thing we know is that the or sine beta is the only thing that is happening horizontally to m. So that is the only force moving horizontally, which means that is exactly our F equals mv squared over or. That is the exact force, or that exact amount is what's causing the circular motion to happen. So what we write down now is we write down mv squared over 8 is equal to or sine beta. Letting one note catch up. Sine beta. So what do we want to do? We know sine beta is 4/5 anyway, don't we? Great. Cool. So why don't we rearrange our first one to get or? Because we want to know the speed, so we want to get rid of m and get rid of or. So let's get rid of or and hope the m just disappears by itself. So this would mean or, this first one would be or is 5 mg over 3. Okay, cool. I think that's going to work. So mv squared over 8 is equal to or, which we know is 5mg over 3, and sine beta, which was 4/5, as we did that at the very start in our nice little relaxing trigonometry. And then that gives us, the m's cancel out, dividing both sides by m, and then on the right divide above and below by 5, and that gives you v squared equals 32 over 3. And I left my trusty calculator somewhere else, so trusty phone calculator. So 32 divided by 3 is that. And then don't forget your g, which I did there. So then we square root that, and we get v is, so which gives you v equals 10.224 meters per second. And then, so again, we're just moving on. Then what we have to do is we have to, I presume friction is going to come into play now. Just scroll ahead. Yeah. Here's senior friction. So a student's second modeling iteration introduces the coefficient of friction mu. And remember, friction is always against the direction of motion. So let's see. Again, it might be useful to draw your arc of your sphere to help your diagram. We have our m here. So again, we have gravity. We're still on Earth as far as we know. We have our reaction, because the bike is touching. And what we have now is friction. So what is friction going to do? I suppose it's going to, if anything, it's going to, on the point of slipping downward. So it's trying to slip down. So our friction force is there. So the friction is like tangential to the circle, or is perpendicular, or normal, if you want to use a fancy maths word, to the circle it's on, but everything else is the same. So there's your diagram. Now I know F and F are going to be confusing. So in the marking scheme, when we're talking about the circular motion force, it says that. So I'll use that if I remember, but you can also just change F to, what do we know? We know F is mu times or. I'm surprised the dogs have the energy to bark in this heat. So that's your diagram. So I might just stick with F as mu or, just because I will forget to do FC and it'll be confusing for you guys. So the mu or, which is friction, is in opposite to the direction in which the thing will slip, which is up. And what we have to do again is we have to decompose our diagonal forces. Now we know that that was beta from our previous question. We know that's a right angle. So I think we know that's beta. I'll leave that as an exercise to you, but that is true. So our forces now are or cos beta up or sine beta in, and that's the exact same as it was. But we also have these two additional things to worry about. That would be mu or cos beta in and mu or sine beta up. I'll just move this guy to over here. Remember, whoops. Sometimes would it just be easier if I just rewritten this anyway. So there's our mu or and our mu or sine beta up. So what are we at now? Again, so now what we do, we look at the horizontals and verticals and see what we can get, what works. So we know the horizontals, so the verticals have to balance each other out. So, actually, what's the question even asking us to do? Oh, Emma's velocity 7.5 when it is on the point of slipping downwards. Calculate the value of mu. Okay, so it gives us v when it is about to slip. So when the ups exactly equal to downs, that's when it's just about to slip. So that's v. So we know v equals 7.5. But I'm going to leave it as mv squared over or for a little while. So what this tells us is, and I'll just read the equations up here, or cos beta plus mu or sine beta equals mg. That's the two ups have to equal the downs. And then our circular motion, which is our mv squared over or inwards to the center, is mv squared over or equals or sine beta minus mu or cos beta. Now I think what we do is we put in the stuff we know, and feel like it's actually the same process. The maths is going to be somewhat ugly, but we're going to get or from the first equation. So from the first equation, if we divide out, separate out or, we're going to get mg over cos b plus mu sine beta. I said b. I'm very grumpy with my students when they call that b. So sorry. So that's what or is equal to. That's not pretty. So that will then mean that m by 7.5 squared, because that's what v is. Sorry. 7.5 squared over 8, because we knew or was 8 from the earlier one, is equal to or by sine beta minus mu cos beta. Now we can put those things back in. Now I'm going to actually write cos beta plus mu sine beta. Actually, no, I won't. I'll just do it all in one god awful thing. So m by 7.5 squared over 8 equals mg over cos beta plus mu sine beta by sine beta minus mu cos beta. Lovely, the m's cancel out, so that's good. Now we need to rearrange stuff, so I'm actually going to do the 7.5 squared over 8 just to get that number. Just 7.5 squared divided by 8 is, so it's going to be 7.0 it's going to be 7.0312. 7.03125, and then we're going to move the g and the cos beta plus mu sine beta over. So that gives us cos beta plus mu sine beta over g equals sine beta minus mu cos beta. but we know what cos beta and sine beta are. So okay, so actually first of all I'm going to get rid of that g. So divide that 7 point thingy by 9.8 and you get 0.71747, and that's multiplied by cos beta, which is 3/5 plus 4 mu over 5, because it's mu sine beta, equals sine beta is 4/5 because it was, minus 3 mu over 5. Oh, and that's a confusing dot. That's not a multiply. Okay, so what we can do now is we can multiply everything across by 5, and that gets rid of the 5s. And what that then gives us is this 0.717 by 3 gives us 2.152 plus 2.87 mu equals 4 minus 3 mu. Then we're going to move that over to go 5.87 mu equals 4 minus 2.152. So I can just do the addition easily. That's supposed to be 5. So 4 minus 2.152 is 1.848. That's 5.87 mu, which means mu equals 1.848 divided by 5.87, which is 0.3148. And for some reason the marking scheme has gone to 3 decimal places, and we are done. Now I kind of sped through that because I know you can stop and start and go back, so please, if you need me to expand on anything I've done here, just let me know. So I'll quickly look at the marking scheme just so we can see where the points were allocated for that. Let's go back to the start. So if you got your diagram right, you got 5. If you did, let's see, where are we? If we got these two equations, that was 5, and if you got the answer there, it was 5. So I'll just say those two, just bracket off there. So if you got your horizontals and verticals and you got 5 marks, you got your answer, you got 5. The next one then, if you got your diagram right, it was 5. Again, the diagram without any of those triangle things, just the 3 arrows or F and MG. Then if you got these equations here, it was 5. Then if you got the answer here, it was 5. So if you got your diagrams and your starting equations, which are going to be the same every single time, ups equal downs, lefts equals right, or left rights make your circular motion force, you would have got 20 out of 30 without doing any of the complicated maths. So you'd hope that you'd get the diagrams bang on and then get a little bit into the question. Maybe get every one of them right, maybe get both of them right, but if you get a bit into each one, you're looking at 22 out of 30 and still getting it all wrong, or 24 out of 30 even, which isn't bad if you get it all wrong. So hopefully we'll get more than that. If there's anything I can expand on with this, just let me know. Yeah, enjoy the proper exam weather.